All right, welcome to video 4 of Unit 8. We're finally going to figure out how to actually determine rate laws. So determining rate laws is honestly really useful, especially if you get data. If you ever get actually into ChemLab yourself, you can actually start making rate laws and again figuring out how to make reactions go faster. You've got the reactants, you can figure out which ones actually directly influence it the most. So they're really useful. Let's get started. So to determine a rate law, following steps will help. First off, construct the rate law with the concentrations of all species for which data is given. Now, I know step 1 basically sounds like saying do it all, but I mean write an idea of what your data is going to look like. For example, let's say you're given a data table and it's got reactants A and B or something. Your rate law then for step 1 would look like this. And then what we're going to do is basically plug in whatever numbers we actually know and kind of solve for whatever's missing. Or for example, if you were given data like with 3 variables, then your rate law could look like this, where it's still rate equals K, but then you just got the different reactants. I use P right here. It doesn't matter at all what letter you use. I just knew if I put a O, people would write it as a 0. So it's just all the concentrate, all the reactants to some power that we're going to be solving for. Secondly, we take ratios of the experimental data for which one reactant's concentration is the same in both. For example, if we were given data like this, if you're looking for A's reactant concentration is the same in experiments 1 and 2. B's is the same in 1 and 3. So what we're saying is basically make the rate law, let's pretend we're going off of A, make the rate law for experiment 1 and plug in these numbers, make the rate law for 2, plug in these numbers, and well, we'll get there. So that would look like this, where this top row is I plugged in these numbers to our rate law. So I said, all right, my concentration of A is 1, so let me plug in 1. I don't know what M yet, we're going to be solving for that, so I just left M. My concentration of B is 2, so I plugged in 2. And I said my overall rate is 5, so I plugged in 5 for my rate. Then I did that for another experiment. Again, I'm trying to pick one where A does not change. So now I plugged in 1, which notice these are the same value. Plugged in 4 for B and 10 for my rate. We'll eventually solve for K, but again, right now we don't know it, so we just plug it in. All right, so that's step 2. Step 3 is we're going to simplify that expression and basically solve for whatever exponent doesn't cancel. And then step 4 is we just kind of do that until we have all our rate orders. So let me bring back that reaction. We have 5 equals K times 1 to the M over 2 to the N, and 10 over 10 equals K times 1 to the M over 4 to the N. So hopefully you noticed, but this K is the same number, and this 1 to the M is the same number. That means we can basically cross those out. We're going to cancel those. So now what we're left with is 5 over 10 equaling to 2 to the N over 4 to the N. My hope is that you remember enough math to realize that this is actually equal to just 2 over 4 to the nth. Okay, basically what you do is we simplify this and we're going to solve for n. So this gets us 1/2 is equal to 1/2 to the nth. Now, whether you know this by common sense, whether you know this by some algebra powers, or whether you go back to that worksheet I gave you that helps you with logs, however you solve this equation, that's cool, because you'll get that n is equal to 1. That means that back in this equation, anytime now we repeat this process, instead of putting n, we'll just put 1. That enables us to cancel out more terms and eventually solve back for m. So again, cancel out what divides, solve for what you're left with. When you've got all your rate orders, you're done with your rate law. Well, now we're going to actually get practicing. So we're going to determine the rate law for this reaction. I'm going to walk you through this one. If you want to try it on your own, go ahead, but I'm just going to kind of talk through this. So first we got to actually determine what the general rate law for this looks like. We only have two reactants, A and B, and the C doesn't really factor in because it's a product. It's not a reactant. So that gets us kind of the standard rate equation. Rate equals K times A to the M some power and B to some power. Okay? Now, we pick two experiments in which either A doesn't change or B doesn't change. Well, the only real option we have is in experiments 1 and 2. B doesn't change. So, we write our ratio of those. That gets us this ratio. Okay, now we cancel out things. We can see that K disappears, and so does our B. This leaves us with that. I took out the M. Hopefully you remember how we do that. That'll simplify down to this. And finally, using logs or however you want to do this, we get that M is equal to 2.